Okay, here's a problem that was sent in from one of your classmates. It's a My Math Lab problem. And it says that the stacked line chart shows the number of college degrees awarded to men and women over time. Complete parts A through D. Well, if we take a look at this, we can see that men are blue. And so the stacked line above the stack of blue boxes is this one that I'm tracing right here. And then when we look at women, which is in purple, that line is above it, and I'm tracing it. So that's the top of the purple or pink stacked boxes. Now let's look at the x-axis, and here's our x-axis. It's a timeline in years, and we start at 1900 and we work our way up to 2000. And if we look at these tick marks, each tick mark represents 5 years. So we have 905, 910, 950, up to 920. So this tells us at what time they measured or calculated the number of college degrees for men or women. On the y-axis is the number of college degrees, and it goes from 0 to 14. But this doesn't represent the individual number of college degrees. It represents the hundreds of thousands of college degrees. So we start at 0 and then 100,000, 200,000, and we work our way up to 1,400,000 degrees. So if we want to know how many college graduates, for example, that there were in 1960, we would start right at 1960 and we would move up until we get to the top of the blue boxes for our men. So at 1960, moving up to the top of the blue boxes, then we move left horizontally until we meet the y-axis. And when we meet the y-axis, we come to a 3. Well, it's not 3, it's 300,000. So, in 1960, the number of college graduates would be 300,000. So let's write that down. So in 1960, the number of men is 3 times 100,000. That's 300,000, and that's men. I'm going to see if I can move that up. Oh, I guess I can't. Okay. So now let's try for women. We'll write up here. And how about women in 1960? So I'm going to go back and get my little pointer, and I go from 1960, I move all the way up, and it looks like it makes it pretty close to that horizontal line. It might be a little bit underneath, but we get to 4. So it looks like it's just less than 400,000. So I'll put approximately 400,000. So this is basically the way we interpret this type of graph, where we have time in the x-axis and we have the number of college graduates in the y-axis, which, remember, it's in hundreds of thousands. Here's another problem. In this contour map, points A here and B here are summits, so they're peaks. The contour lines have 40-foot intervals. That is to say, if you move from one contour line to another, you've increased in height by 40 feet. In this problem, it asks if you walk from A to C, are you walking downhill or uphill? Well, since A is a summit, it's a peak, as we walk away from A towards C, each time we walk through a new contour interval, we decrease our height by 40 feet. So we're going to continue to decrease by 40 feet with each contour line until we get to C, which means from A to C, we will be walking downhill. The next question is, are you going to change more in elevation by declining from B to D, or declining from D to F? Well, if we look at the decline from B to D, we see many contour lines. And each time we pass a contour line, we are dropping 40 feet in elevation. So as you can see, from B to D, there are many more contour lines than from D to F. Here from D to F, we have only 1, 2, 3, 4, 5, 6 contour lines, which is 6 times 40, or 240 feet that we will drop. So we will actually change more in walking from B to D in elevation, and we will have a smaller decline in elevation going from D to F. The last question is, when we walk from E to F, how does our elevation change? Well, it doesn't. In fact, it stays the same because they're within the same contour lines. So the change in elevation should be negligible.